Assalamu alaikum, this is AS Chemistry and today we're doing yield. We're going to go through what theoretical yield is, what actual yield is, and then we're going to see how to calculate percentage yield when you've been given both the theoretical and the actual yield, and how to calculate percentage yield when you've only been given actual yield. So when you talk about theoretical yield, you're talking about the maximum amount or mass of product or products that is obtained from a given mass of reactants, and you assume there are no losses. So for example, in a reaction you say, well, 2 grams of X reacted with 3 grams of Y. Assuming there are no losses, you get 5 grams of the product Z. Okay, so this is what theoretical yield is going to be, right? You're not going to consider let's say if a reaction had some water in it, okay, and you lost the water as steam as the reaction was occurring, you're not going to consider that in theoretical yield, okay? You also don't consider any of the mass losses of the reactants due to the damage in the equipment, okay? So that's theoretical yield there. When you talk about actual yield, you're talking about the amount or mass of product you actually obtain from doing the reaction in a lab, okay? So it's an experimental data and it's not from the calculations, and you don't have any assumptions here. You consider all the losses during transfer of the reactants from one flask to the other, from one container to the other. Also the losses of product during purification, or you consider any side reactions that are going on, okay? And you also consider whether the reaction went to completion or not. When you talk about, by the way, when you're talking about theoretical yield, you're assuming the reaction was a complete reaction. Here, you're not having any of those assumptions, okay? So you consider losses during transfer or purification of the product, okay? You also consider any side reactions that are going on, and you also see if the reaction went to completion or not, or whether it was an incomplete reaction or not. All right. So when you consider all of these losses, you come to realize that actual yield is often less than the theoretical yield because of all of these losses. Now, when we talk about percentage yield, we're talking about the overall yield. Okay, so I should write this here for you. There is no space there. So percentage yield is the overall yield expressed as a percentage of the theoretical yield, okay? It tells you how efficient the reaction was. So you can say, well, how much of the product you actually got compared to the maximum possible, okay? So in theoretical yield, you calculate this is the maximum possible, okay? Without considering any of the losses. In actual yield, you figure out, okay, well, this is the actual amount we actually got, okay? So you use both of those to calculate percentage yield. So if there was a formula, which we do have, for percentage yield, that is actual yield divided by the theoretical yield, okay, and you times this by 100 because it's percentage. So let me just show this here. So okay, and because it's percentage yield, okay, because of this, it can never be more than 100%, okay? So let's say if you calculate in a reaction, you calculate the percentage yield of a reaction, and you get something like 102, that's going to be wrong because it's a percentage yield, so it's never going to be greater than 100, right? A reaction can be 100% efficient, but not more than 100, right? So if you get an answer that's bigger than 100, then you might need to check your procedure, your data again. So we have a question here. If we can get this. All right. So the question says, in an experiment, 5 grams of copper was heated in air to produce copper oxide. The theoretical yield of this reaction was 6.26. It's very important that you pay close attention to what data you've been given. So you've already been given the theoretical yield in the question. When copper oxide was weighed, it was found to have a mass of 5.23 grams. Calculate the percentage yield. It's very important to understand the question. So you do have the theoretical yield. Where is the actual yield? Okay, if we just try to write down the equation for this. So you have copper was heated in air. So air, oxygen there, to produce copper oxide. Okay. I could balance this, but I'm not getting into this because it's not needed to balance the equation. In fact, you're not needed. The equation is not needed at all. But just for the sake of explaining, you had 5 grams of this, okay? You reacted it in air, okay, or heated it in the air, which means this was in excess, okay, to produce copper oxide. And the theoretical yield means what you calculated without considering the losses was 6.26. So it's very easy from the question to figure out what the actual yield was. It's this. It cannot be 5 grams because that was the mass of the reactants. The product, which is copper oxide, was found to have a mass of 5.23. Okay, and I told you that actual yield is the experimentally determined mass of the product, which is this. And so now we just need to calculate the percentage yield. We have both the actual and the theoretical yield. Theoretical yield is 6.26 grams. Actual yield is 5.23 grams. So if you calculate percentage yield for this reaction, actual yield goes at the top, so that's 5.23, okay, divided by 6.26 grams, and times that by 100, and I have this already calculated for you, so that's going to be 83.5 grams. Try to give answer 1 decimal place, okay? Answer in 1 decimal place. So you get this was a super easy question. All you had to do was figure out where the theoretical yield is, where actual yield is, what to ignore, and then just use the formula to get the percentage yield. Then we move on to the scenario where you've not been given theoretical yield. So it's not very complex if you think of it in terms of structured, organized steps. Then it's very easy to calculate the theoretical yield and then use that to calculate the percentage yield. So before we do this question, I would like to highlight a general method or general steps for calculating yield in any question, okay, when you've not been given the theoretical yield. So it's very general, but it's going to make sense when we start doing the question. So steps for calculating yield. All right, so the first step is to calculate the moles of the reactant whose mass is given. So calculate N, which means moles, of the reactant whose mass is given. All right, the second step is to use the balanced equation. You might be given this equation if it's like a 2 or 3 marker, and you might not be given the equation if it's like a 3 to 4 marker. Then you'll have to read the question, figure out what's the reactant, what's the product, make the balanced chemical equation, and then use the equation for the calculation. So the second step is to use the balanced equation. Use the balanced equation and the ratio. Okay, you're going to get a ratio from the balanced equation, right? to get the moles of the product. If I go back to my previous example here, which was 2 grams of X plus 3 grams of Y makes you 5 grams of Z. So in this equation, let's say it's a balanced chemical equation. So let's say you had the mass of this reactant known. So you calculate its moles using the mass that's given using this formula, if you don't already know this. Okay, so you calculate the moles of X, okay? Then you use the moles of X, okay? You do the ratio, so the ratio between this and the product is 2:5, okay? So whatever moles of X you had, you use that to find the moles of Z, okay? All right, so that's your second step. The third step is going to be to use the moles and the molecular mass of the product to find the mass of the product. Okay, that's interesting. So you use the moles to find, you use the moles plus the MR to find the mass of the product. The mass tells you the yield. Your mass, which you're going to find using this, is going to be your theoretical yield. Okay, once you have your theoretical yield, you can now use this formula. Percentage yield is equals to actual over theoretical. I'm just going to write TY times this by 100. All right, so now let's try and use this method here. So trying to use this method here to solve this question, okay? So let's see how this method is going to work for every question. So the first step says that we need to calculate the number of moles of the reactant whose mass is given. So let's go to the question. So the question says 0.475 grams of CH3Br reacts with excess NaOH in the following reaction. We have the equation here. Okay, we see that this CH3Br is the reactant, and we have been given the mass. We've been given the mass of the reactant. So let's not read the question further and follow the steps. So I'm gonna find the moles of CH3Br because its mass is given and it's a reactant. So I can find the moles using the M over MR formula. So for me to be able to use that formula, I first need to work out the MR of CH3Br, which I have already done for you guys so we can save time. So CH3Br has a molecular mass of 94.9 grams per mole. You can use your periodic table for this. Then you use this MR and the formula, which is M upon MR, to find the moles. So M here is going to be 0.475. 0.475 divided by 94.9 is going to give you your moles. And so when you do the calculations, you get 0.0050 moles. All right. So we're done with the first step. We found the moles of the reactant whose mass was given. Then it says to use the balanced equation and the ratio to get the moles of the product. Okay. Using the moles of the reactant that we've already found. So the equation gives me a ratio between CH3Br and the main product, which is this. Okay. It gives me ratio of 1 to 1. So ratio between CH3Br and CH3OH is 1:1. If the ratio is 1:1, then it means the number of moles of CH3OH is the same as the number of moles of CH3Br. So 0.0050 moles of CH3Br will produce 0.0050 moles of CH3OH. So this we're gonna write here. So we have the number of moles of the product using the balanced chemical equation. So we're done with the second step. Then we move on to the third step, which says use the moles to find the mass in MR. Moles in the MR of the product to find the mass of the product. Okay, so I do have the moles. I can use this formula. So the MR, I already have it calculated here. So the MR of CH3OH is 32.0 grams per mole. So now I can use the formula. So making M the subject, I'm gonna get N times MR, which is going to give me the theoretical yield. This mass of CH3OH is the theoretical yield. All right. So if I do this, that's going to be 0.0050 times 32.0, and that should give me 0.160 grams. All right. I have the theoretical yield here. Now, this is the theoretical yield of ethanol. Okay. Now, once I have the theoretical yield, I've already been given the actual yield. This is the actual yield. Okay. 0.153 grams of ethanol is produced. So now I can use the actual yield and the theoretical yield to find the percentage yield. So the actual yield over theoretical yield times 100. I plug in my values, 0.153 divided by 0.1660 times this by 100, and it's going to give you a percentage yield of 95.5%. And that's it.